This video covers introduction and overview of one-dimensional arrays. There are two videos, number 7 and number 8. This is the first one, and what we will overview here is to show that arrays are a compound data structure. Arrays can store elements only of the same type. It can store primitive types as well as objects, and it stores data in contiguous memory locations. They're of fixed size, and they provide indexing for fast access. The rest of the material with regard to examples and 2D arrays as well as the arrays.util is going to be covered in the next video, that's VL8 and the second video of this week. So let's get ourselves a new slide and talk a little bit about what arrays look like. For example, so let's declare an array, which is a compound data type. And I'm going to say integer, square bracket, grades equals new int. And here is where I'm going to put a size. Now, as you can see, this is different from the regular declarations that we've been used to, where we have a single variable x, which can only store one value. And let's say if we say int x is equal to 5, then that's what's going to go into this memory box. This is a bigger declaration. And what this says is I'm going to have not just one single box, but as many boxes as I'm going to put in here. And if I were to put the number 100, I've got myself 100 boxes. And I'm going to label or index them from 0 all the way to 99, making the total count 100. This kind of structure where you can have a database or a bunch of elements all stored right next to each other in contiguous memory locations is called an array. So contiguous means right next to each other. We need to have an array to be contiguous in memory because we want to index the boxes from 0 to 99. So this is element 0, this is element 1, 2, and so on all the way to 99. Why do we need arrays? We have lots of applications where we might need to access, for example, related information like grades. And let's say we have 100 students in the class and we want to have grades that correspond to each one of those students. Then it makes sense to say, I'm going to have a roster, a grade roster, and this is what my grade roster is going to look like. What I would not want to have is hundreds of variables, integer x1, x2, x3, all the way up to x90, x100, corresponding to the grades of 100 students. This is very bulky, cumbersome, and sometimes it's just not impossible. Sometimes it's just not possible. So we have one name which stands for the grade roster, and when we index into the roster and saying this is student number, this is the first student and represented by index 0, second student represented by 1, and the 100th student is represented by 99. So we must keep track that there is a 1 off with regard to the numbers. When we say first, we actually mean index 0. The array utility grades.length, it gives us the number 100. So this is a method that easily allows us to get the length of the array, right? Now, the other thing that we need to keep in mind is because we are getting memory from the computer, all of these elements need to be of the same size. You cannot have an array in which one of this is a double, one of this is a string, and this is an integer. All elements are of a fixed size so that the entire array is of a fixed size of integer. And if on your computer you have an integer which is 4 bytes long, then we're talking about 400 bytes of storage here, right? So this is with regard to an overview of array indexing, array length, and array declaration. Now what we'd like to do is talk about reference semantics for a little bit. What do we mean by reference semantics? Especially with related to parameter passing. To go back to our grades array, we got ourselves this big array of 100 elements, 100 integers at a particular memory location, and let's say this is 3154. Now, it's important to keep in mind that addresses are important to access information, but when we pass information, then it's definitely cumbersome to pass large amounts of information. Just as an example, if you wanted someone to deliver a piece of furniture into our house, we would not take our house to the furniture store, but rather we would give the address of our house and the furniture would get delivered and stored inside or picked up. So exactly in the same way, when we have a large bulky piece of data, we wouldn't want to move it around because there are space and time constraints and complexity constraints. And where do we want to pass information? Usually we pass information in and out of methods. So that's brings us to the next piece of inspection, that is, if we have bulky information, how can we have a method access a database like an array? And let's say this is our grades array. Then I'm going to have a method here, public static void, and I'm going to say total grades, and I'm going to pass my information here. I'm going to say my integer grades. So the address 3154, not the entire database, but the address is going to get passed here. And then you can traverse the array here by saying, just having it, if you wanted to pass it back, I could change this to a double and say double total equals 0 at the beginning, and then traverse the array for integer I is equal to 0, I less than grades.length I plus plus. Then I could say total plus equal to grades I. So my method total grades is now inside going to the address 3154, which is exactly this place, and accessing or reading the information. So this is passing by ref or reference semantics, where we don't need to pass the entire database in and out. Know that here a double value is getting returned, so I have to return the total. I would like to talk a little bit about, do we really need to return an array? So let's go back and say I have a public static void mischief, and this takes in my grades array. And what mischief is doing is it's traversing it says if grades I is less than 60, then what we are going to do is grades I plus equals 20. So mischievously bumping up someone's grade, which is kind of like a failing grade, and then adding. Now know that here again the address 3154 is passed, so mischief has access to the database. And what mischief is doing is, if this were 90 and this were 50 and this were 35, what mischief has gone and done at address 3154 is it's bumped this up, and so now this is 70, bump this up, and now this is 55. So while nothing has gotten returned, this is void, but changes have actually been made to the array. And if we went back to the main program, right, which called mischief and passed grades to mischief, and then if we print mischief, if we print grades, then the new updated grades after the mischief is going to get printed. And this change is permanent. So we can see that we do not need to return an array. We can make changes inside the array. Sometimes, of course, we might want to return an array. Let's say we would like to do a computation in which we would like to keep the database intact as it is, but we would like to do some computations based off the data and return that information. So for example, if I genuinely wanted to bump up students' grade to see what the final grades are going to look like, I can do something like public static integer and then legit and then pass grades. And now I would do the exact same thing, but because I need to pass one, I'm going to declare myself integer new grades is equal to, now look what I'm doing here, new integer. What's going to be the size of this one here? It's going to be the same as the size of the incoming array. So I'm going to do grades.length. So I can here not just put a number, but I can use an expression as well. And then what I will do is I will do the same thing for integer I is equal to 0, I less than grades.length I plus plus. I'm going to say new grades is equal to new grades I is equal to grades I. And of course, if grades I is less than 60, then new grades I plus equal to 20. And when I'm done with all of this, so here I've only accessed, it's on the right side. It's on the right side. I have not put it on the left side. And now new grades has accessed the database, but I've created a new database inside. And when I'm done with all of this, I'm going to return new grades. And if I would like to, so here's what my method inside the main program, it's going to look like integer new grades is equal to legit, right? This is a program, and pass grades. So what gets returned from grades is going to be stored inside the main program into an array called new grades, and then we can say system out println arrays dot toString new grades, and we can do that. If we wanted to just print the last grade, how to print the last grade, we can access this by saying the last grade is accessed by new grades, and note here new grades dot length -1. So there's this big expression here inside the square bracket. So if the new length arrays dot length, the new grades length is equal to 100, then this is going to be 100 -1, and this is going to be 99, which is exactly the last element. So this covers our overview of very basic array declaration, array parameter passing, array return types, array traversals, and array access. In the next video, we will go over and deep dive into some examples of array utilities, how to traverse two-dimensional arrays, and also and then just point to an example of the magic square, which is part of your practice it assignment.